Hopefully you've had a chance to think about that rather than just observing the answer. You've had a chance to think through the answer. And let me give you another question in case you haven't managed to reason that out. Let's ask, here's a diagram, here are the two ramps. I've labeled x1, 0 and delta x2 here. x1, 0 being the distance back from the point where the ramps join to the point where the first ball is released. Delta x2 being how far the ball goes up the second ramp. You've already seen that in some cases delta x2 might be greater than x1 naught, and in some it might be less. Okay, let me ask, what if the first ramp is twice as steep as the second? Then how will delta x2 and x1 naught be related? Think that through in terms of the analysis we've just done. Because what we've got is actually a very simple and straightforward result. So give that some thought. Okay, if you haven't given it some thought, pause and do so now. Last spoiler alert, I'm going to go on. Okay, now, well, if the first ramp is twice as steep as the second, then this implies that S1 over S2 is 2. The first ramp has twice the slope of the second. I say twice as steep, and steepness isn't necessarily a well-defined quantity, but I think it should be clear what I mean. It has twice the slope, and that's what we would generally want to mean when we say twice as steep. Okay, so the first ramp is twice as steep as the second, so S1 over S2 equals 2. So delta x2, the distance on the second ramp, is S1 over S2, which is 2 times x1 naught. That is, ball goes twice as far on the second ramp. Now, if the second ramp is twice as steep, that's only going to go half as far. Now remember, we haven't taken account of friction or that little bump at the middle. We haven't gotten a handle on that at all. We just know what would happen if there was no friction. And, well, rotation of the ball comes into it also, but we're not going to talk too much about that just yet. Plenty later. Okay. So what we're saying here is then that distance on the second ramp is S1 over S2 times the distance on the first. It's just a simple proportionality. You look at the ratio of the two slopes and you get the ratio of the two distances. Now in the next segment we're going to go on and talk about a simpler way to have analyzed this.